Okay, 6.3 Lee Chatelier's principle. At the end of this lesson, you should be able to apply Lee Chatelier's principle to explain the effect of the following factors on a system at equilibrium for the effect of temperature and catalyst. The effect of temperature. The effect of temperature on equilibrium position and equilibrium constant depends on the type of reaction, such as exothermic or endothermic reaction. Okay, in endothermic reaction, the reaction will absorb heat from the surrounding. So consider the following reversible reaction between reactants and products. So the change of enthalpy, okay, delta H, is in positive kilojoule, means positive value. Or we can put heat beside the reactants, because in endothermic reaction, in order to produce product, it must absorb heat from the surrounding. So we put heat beside the reactants. Okay, now look at the exothermic reaction. Exothermic reaction will release heat to the surrounding. So if we have reversible reaction between reactant and products, the change of enthalpy, delta H, is in negative value. Or we can put heat beside product, because in exothermic reaction, the product is formed when the heat is released to the surrounding. The energy profile diagram. In exothermic reaction, we can see that the product formed by releasing heat to the surrounding. So we put heat beside product. So the change of enthalpy is negative. So we can calculate the change of enthalpy by using the formula of enthalpy of product minus the enthalpy of reactant. Okay, and because of the enthalpy of product is less than the enthalpy of reactant, that's why the change of enthalpy is negative. Okay, now if in endothermic reaction, we can see in order to produce product, the reactant absorb heat from the surrounding. So we put heat beside the reactant. The change of enthalpy is in positive. Okay, because we can see that here the change of enthalpy, the enthalpy of product is higher than the enthalpy of reactant. So that's why the value will be positive. Endothermic reaction. We know that an endothermic reaction will absorb heat from the surrounding. But the question is, how do we know the reaction is an endothermic reaction? So by looking at the change of enthalpy. So if the change of enthalpy in positive value, means the reaction is endothermic reaction. So if endothermic reaction, we put heat besides the reactants, means heat is just like the component on the left hand side. Okay, now we look at the first case. So the first disturbance is we increase the temperature. So the first to write is by identify the type of reaction. So the reaction is endothermic reaction. So when the temperature is increased, the system will react to decrease back the temperature. So how to decrease the temperature is by decrease heat. And because of heat is on the left-hand side, so the system will shift to the right. Okay, now look at the second case. The disturbance is decrease in temperature. So again, the reaction is endothermic reaction. So when the temperature is decreased, the system will react to increase back the temperature. So how to increase the temperature is by increase heat. So how to increase heat? So the system will shift to the left to increase heat. Exothermic reaction. An exothermic reaction release heat to the surrounding. So how to identify this is an exothermic reaction? By looking at the change of enthalpy. So if in negative value, mean it is an exothermic reaction. So we put heat beside the product. Okay, now look at the first case. The first disturbance is we increase the temperature. So first is the type of reaction, exothermic. So when the temperature is increased, the system will re-establish to decrease back the temperature. So how to decrease the temperature? By decrease heat. So how to decrease heat? So it will shift to the left. Okay, because heat is as a component on the right hand side. Okay, now the second case, the disturbance is the temperature is decreased. So the type of reaction still exothermic reaction. So when the temperature is decreased, the system will react to increase back the temperature. So how to increase the temperature? By increase heat. So how to increase heat? The system will shift to the right to increase heat. Change in temperature. Only temperature change can alter K. So in exothermic reaction, consider this reversible reaction. If the change of enthalpy, delta H in negative value, so we put heat beside the product. So the Kc can be written as the concentration of product PCl5 divided by the concentration of reactants. So PCl3 and Cl2. So now the disturbance, the change. So the disturbance is we increase the temperature. Increase the temperature means increase in heat. Okay, increase in heat. So the system will react to decrease back the heat. So how? By shift to the left. So if shift to the left, the Kc value will be decreased. Okay, so if we decrease the temperature, means just like heat is decreased. So when the heat is decreased, the system will increase heat. So how to increase heat? The system will shift to the right. So if it shifts to the right, the Kc will be increased. Okay, now in endothermic reaction, the value of delta H is positive. Okay, so we put heat besides the reactant. Okay, so the Kc can be written as the concentration of O2 divided by the concentration of SO2. S is not written in expression because S in pure solid. So the concentration is remain constant. Okay, now the change, the disturbance. We increase the temperature. So if increase temperature means increase in heat. So the system will reduce heat by shift to the right. So because of its shift to the right, the Kc will be increased. And the second one is if we decrease the temperature, just like the heat is decreased. So if the heat is decreased, the system will increase heat. How to increase heat? It will shift to the left. So when it shifts to the left, the Kc will be decreased. On the following reaction, predict the direction of the equilibrium when 1 mole of N2O4 produce 2 mole of NO2. Okay, so first is by looking at the delta H. Because of the delta H is positive value, means the reaction is endothermic reaction. So make sure you put heat beside the reactant. So when the temperature increase, means heat increase. So of course the equilibrium position will shift to the right to decrease heat. Okay, so when the temperature is decreased, means heat decrease. So when heat decrease, the system will increase more heat. So it will shift to the left. Based on the following reaction, predict and explain the direction of the equilibrium when 3 mole of H2 gas plus 1 mole of N2 gas produce 2 mole of NH3 gas. Okay, now the disturbance. The temperature is increased. So the first step is by identify the type of reaction. So the reaction is exothermic. Why exothermic? Because the delta H in negative value. So if exothermic reaction, we put heat besides product. So when the temperature of the system is increased, the equilibrium will re-establish to decrease the temperature of the system. Thus, the equilibrium position will shift to the left. Okay, now the second disturbance, the temperature is decreased. So still the reaction is an exothermic reaction. So when the temperature is decreased, the equilibrium will re-establish to increase the temperature. So the system will shift to the right. Exercise. Okay, please answer these questions in order to achieve learning outcomes in this subtopic. Next effect on the equilibrium is the effect of catalyst. So a catalyst is a substance that can speed up a rate of reaction. How? By providing an alternative mechanism with lower activation energy. So catalysts do not affect the equilibrium position in a system because a catalyst affects both forward and reverse reaction equally. So it will increase the forward and reverse rate to the same extent by shorten the time taken to reach equilibrium. But remember, catalyst has no effect on the equilibrium position and the value of Kc. Okay, so now we have two figures of energy profile diagram. So as you can see, the activation energy in catalyzed, uncatalyzed energy profile diagram is higher compared to the activation energy in the catalyzed energy profile diagram. So that means the catalyst will lower the activation energy for both forward and reverse reactions. Thus, the catalyst will speed up the rate of reaction for both forward and reverse reaction. Based on the following reaction, explain what will happen to the position of equilibrium when a catalyst is added. So the answer, no change to equilibrium, because catalysts are only substances that speed up the reaction by providing an alternative pathway which has lower activation energy. So catalyst does not affect the equilibrium position. The catalyst only allows the equilibrium position to be attained faster. Okay, as a conclusion, if we change the concentration, so shift in equilibrium, yes. But change in the value of K, no. If we change the pressure, shift in equilibrium, yes. Change of K, no. If we change the volume, shift in equilibrium, yes. Change in K, no. If we change the temperature, shift in equilibrium, yes. Change in K, yes. But when we add catalyst, shift in equilibrium, no. Change of K, also no. Okay, so that's all for now. Thank you for watching.